Hello friends, welcome to the course Exploratory Data Analysis for Data Science with R software. So now we are approaching towards the end of the course, and up to now you have seen that you have learned many topics which are related to exploratory data analysis. And we started with the measure of central tendency, then we learned about variations, and then we learned about this correlation coefficient and so on. So, different measures of central tendency, variation and association of variables. These are the three main topics which we have broadly covered in this course. So, now the next question comes, whatever topic we have done here, we have considered one variable. For example, when we talked about measures of central tendency or measures of variation, we have considered one variable at a time. And when we talked about, say, covariation or say correlation coefficient, then we considered two variables because we wanted to understand the joint relationship. But in practice, what happens that usually we have more than two variables in most of the real life issues. So now how can you extend the concept which you have learned about central tendency, variation, correlation, etc., to a multivariate setup? And this is very simple. Whatever you have learned up to now, just by using the same knowledge, you can extend it to a multivariate setup. So, in this lecture and in the next lecture, we are going to talk about this handling the multivariate data. And my objective is very simple. I am not going to talk about here the multivariate analysis, which is a full-fledged course in statistics, but I am simply going to tell you that the tools of exploratory data analysis like as mean, variance, covariance, correlation, you have studied in this course how you can view them in a multivariate setup and how you can implement them in the R software. So, in this lecture, we are going to talk about two aspects, which is the sum and mean in case of multivariate data, and in the next lecture, we will be talking about, say, this variation and correlation in the multivariate data. So, I will take a very simple approach over here just to give you a confidence and convince you that it is not difficult to extend the univariate into multivariate, but how you can do it, that I would like to show you. So, let us begin our lecture and try to understand it. When there is only one variable, then we consider the univariate analysis. And when we have more than one variable, say two variables, suppose my one variable I am trying to express as say x1, and when we have two variables, then suppose I express them as say x1 and x2, then we try to write them in the form of a vector. Now, this vector is a mathematical vector, the vector of the matrix theory, right? And based on that, whatever analysis we do, this is usually called as bivariate analysis. Similarly, when there are three variables, say x1, x2, x3, then we try to write them in the form of a vector. So, and then I write here x1, x2 and x3. So, this becomes here a 3 cross 1 vector. So, this vector is not a data vector, but it is the vector of the from vectors and matrices, right. And based on that, when we try to do the analysis, that is actually trivariate analysis. And similarly, if you have more than two variables, say p variables, suppose x1, x2, say here xp, then we express them in the form of a vector here like this, all x1, x2, xp in the vector. So, this becomes here a vector of order p cross 1, and this is denoted as here say x underscore, which means here x is a vector. And based on this, when we try to do any analysis, that is usually called a multivariate analysis. All right. There are various tools of multivariate analysis in statistics, and but we are not going to discuss about them here. But my objective is to show you that how you can think about from one variable to two variable to three variables and so on, and how you can work with the same concept which you have used earlier. So, suppose we talk about the mean vector. So, when you have only one variable, in the case of univariate analysis, you had only one mean, and we denoted the mean of x1 here as a x1 bar. And now, when you consider bivariate analysis, then there will be two variables, say x1 and x2, and both of them will have their own means. So, mean of x1 we are representing by here x1 bar, and mean of x2 we are representing here by x bar 2. Now, when we try to consider the bivariate analysis, that means we are interested in a joint variation. Yeah, it's important to understand here that when we are talking about the bivariate analysis, trivariate analysis or multivariate analysis, that means we are interested in having the joint analysis. For example, in case of bivariate analysis, how x1 and x2 together are working. In trivariate analysis, how x1, x2 and x3 they are working jointly. And similarly, when we are talking about multivariate analysis, then how x1, x2, xp, p variables are working jointly and how they are impacting the process. So, similarly, when we are talking about bivariate case, then x1 and x2 will have mean of say x1 and mean of x2 as say x bar 1 and x bar 2. Now, we want to express them in the form of a vector, which is called as mean vector. So, say mean of this x1 and x2, which is x1 and x2 are written as say 2 cross 1 vector, then I can take this mean operator inside, and it becomes here mean of x1 and mean of x2, which is again a p, say this here 2 cross 1 vector. So, this is now my here a mean vector of x bar 1 and x bar 2, which is of order 2 cross 1, right. So, this is the concept of actually here mean vector, that all the mean values are arranged in the vector, and this vector is from the concept of vectors and matrix theory. Similarly, if you try to consider here a trivariate situation, then there are three variables x1, x2 and x3, and they have got here mean vectors x1 bar, x2 bar and x3 bar. Now, we can combine them in the form of a mean vector. So, mean of this x1, x2, x3, which is now here a 3 cross 1 vector. So, you try to write down here mean of x1, mean of x2 and mean of x3, and this becomes here x1 bar, x2 bar and x3 bar. So, their vector. So, this mean vector is also of order 3 by 1. And similarly, if you are going for here multivariate setup, then suppose you have here variable x1 having mean x1 bar, variable x2 having mean x2 bar, x3 having mean x bar 3, and similarly here xp variable having mean as here x bar p. So, this all this x1 bar, x2 bar, x3 bar, xp bar, they all are univariate, and now we combine them in the form of a mean vector. So, mean of this x1, x2, xp, which is here a p cross 1 vector, will become here as mean of x1, mean of x2, mean of xp, and this can be written here as x bar 1, x bar 2 and here x bar p. So, this mean vector is also of order say p cross 1, right. And now, let me try to take here a very simple example to show you that how you can operate it in the R software and how it is going to make a difference where you have to be careful. So, we consider here a sample of the data set of 4 observation, where there are 4 cars, car number 1, 2, 3, 4, and their mileage have been recorded. So, that how much petrol in liters they have used and then how much kilometer they have run. So, car number 1 has used 5 liters of petrol and then covered say this 90 kilometers. Car number 2 used 4 liters of petrol and covered 100 kilometers. Car number 3 used 6 liters of petrol and covered 80 kilometers, and car number 4 used 7 liters and covered 125 kilometers. So, this data has been stored in the form of say these 2 data vectors, mileage and petrol, and then when you are trying to consider them as a matrix, then you have to first convert this data into a matrix. So, what I try to do here, I try to create here a matrix of order 4 by 2. How? If you try to look at it, this is also an order of matrix 4 by 2. Same thing I try to write down here to give them a matrix format, MATRAX matrix, n row equal to 4, 1, 2, 3, 4 rows and 2 columns, n col equal to 2, and data is equal to what? Data vector of mileage and petrol. So, you can see here, and then this data is stored in car mat, means car data in matrix format, car mat. So, and it looks like here like this. So, you can see here this data is exactly looking like this, right. So, now when you are trying to look at this data in the matrix format, then there are two possibilities of find the mean vectors, either row wise or say column wise, right. So, if you try to see here in the R software, there are commands for finding the sums and means, and they are column wise. So, there are two commands for finding out the sums, which is a row wise sum, column wise sum, row wise mean and column wise mean, right. So, the commands here are, if I say call sum, COL, capital S, and then after that lowercase UMS, call sums. So, this will calculate the sum of the values in the columns of the matrix X. Similarly, if I consider here row sums, in which capital S is there in the sums, that you have to be careful. This calculates the sum of values in rows in the matrix X. And then if I simply use here col means and row means, COL MEANS, where M here is in capital letters, this will calculate the arithmetic mean of the values in the columns of the matrix X. And similarly, row means ROW MEANS, where M is in the capital letters, will calculate the arithmetic mean of the values in the rows of matrix X. And this X is say an array of 2 or more dimension containing numeric, complex, integer or logical values, or it can be a data frame also, right. So, now let me try to take here the same example, that what do you really mean by row sums, columns and their mean. So, if you try to take this data set, when I am making the sum of the values row wise, then it is row sum. If you try to see, if I say 90 plus 5, it is here 95, this is here row sums. 100 plus 4, this is here 104, 80 plus 6 is here 86, and then 125 plus 7, this is 132, this is row sum. And when I am trying to find out their arithmetic mean, so for example, if I try to divide the row sums by the number of observation 2, 95 divided by 2, 104 divided by 2, 86 divided by 2, 132 divided by 2, then we get here the row means, right. 95 divided by 2 is equal to 47.5, and similarly 132 divided by 2 is 56.0. Now, similarly, if you try to see here, if you go here column wise, so if you try to find out here the sum of 90 plus 100 plus 80 plus 125, this is 395. And similarly, here the sum of the columns 2, that means the values in the column 2, they are summed together. So, 5 plus 4 plus 6 plus 7, it is here 22. And in case if you try to divide this 395 by 4 values and 22 divided by 4 values, then you get here the column means. That means the arithmetic mean of the values in the columns 1 and 2. Now, the same thing you can obtain here from the command here call sums of car mat. So, you can see here you are getting a 395 and 22. So, these are the same value which you have obtained here. Then you try to use here the command here row sums, ROW capital S UMS car mat. So, row sums you can see here these are the 4 values which are coming here, right. Then you are trying to find out here call means of this car mat. So, these are 98.75 and 5.5 which are here coming to be here like this. And after that you are obtaining here row means of car mat. So, these are the 4 values which are coming here in the row means. So, this is actually what we mean when we try to find out these values actually, and here it is the screenshot of the same operation, but let me try to show you these things on the R console actually. So first let me try to give you here this, enter the data here. So you can see here is the data, this is your here data in the car mat, and now if you try to use here these options here, say call sums of this here car mat, you get here the values of the column sums. If you get here the row sums of this car mat, you get here the values of here row sums. And similarly, if you want to have here the row means and column means, so you can see here, this is here, see here col means of car mat, it is here like this, column means of the arithmetic mean of the columns of the this data matrix. And similarly, if you try to see here, this is here row means, right. So you can see here it's not difficult actually, but the only thing is this, you have to understand that what you want and how you can obtain it. Similarly, I try to take here one more data set, and I will continue to use this data set in the next lecture also. So here there is an observation of 20 students which is collected on say here 4 variables. The marks of a student which have been scored out of 250, the number of hours of study in a week which is indicated by here x1, number of assignments submitted in a month, that is x2, and number of hours of play in a week, that is x3. So this say 20 observations are like this, that the student number 1 has studied 34 hours in a week, submitted 3 assignments in a month, and played 15 hours in a week and has got 180 marks. Similarly, the second student has got 116 marks, and that student actually studied 12 hours in a week, submitted 1 assignment and played for 13 hours in a week, and so on. This data is given here, right. So we know that the marks of the student depends on all such factors, right. So I write all this data in the same variable name x1, x2, x3 and here y in the data vector, and then I try to create here a data matrix, data mat of matrix with n row equal to 20. That means all the observations n call equal to 4 containing y, x1, x2, x3, and then data which is in the format of data vector of c, y, x1, x2, x3, right. So now you can see here, this is how the data will look like. So if you try to see, this is the same type of matrix which is given here. If you try to create this, write all the data in the form of a matrix, it will look like this. This is not difficult at all. Now in this case, if you try to see here this, if you try to see here the call sums. So call sums, there are here 4 values, 3396, 552, 56, 311. So what are these values here? If you try to see, you can see here, this is my here first column whose sum of all the values is given here as say 3396. Then I have here the second column whose all the values are added and its sum is given here as say 552. Then in the third column, all the values are summed and their values is given here say 56. Similarly, in the fourth column, all the values are added together and their value is given here as a 311, right. And similarly, if you try to see here, there is another say here row sums. So row sums, there are here these values over here which are like this, that sum of the values in the first row, this is given over here 232. Then sum of the values in the second row, this is given as 142, and similarly all the values in the last row, they are given as 251. And now if you try to see, I am trying to operate here the command call means data mat, mean the means of the values in the column. So there are here 4 values. So you can see here that in this case, these are my column means, that this is first value is the mean of the first column, second value is the mean of second column, third value is the mean of third column, and fourth is the mean of the values in the fourth column, right. And then finally, we have here row means of data mat. So all these values which are here in the row wise, their means are given here. Say 58 is the mean of the values in the first row, 35.50 is the value of the is the mean of the values in the second row, and so on. So you can see that it's not a very difficult thing, and I will just try to show you it on the R console so that you develop some more confidence. Right, so you can see here, this is your here data mat. Right, so now if you try to see here, I try to find out here the column sums, which is here like this, and then I try to find out here the row sums. So these two commands will give me the sum of all the values in the 4 columns and 20 rows. Then I try to find out here the means of the values in the column. So there are 4 columns, so there should be 4 column means, and then I try to find out here the row means. So you can see here there are 20 rows, so there are 20 row means. So you can see here it's not a very difficult thing to operate, but it is more important to understand it conceptually, right? Because when you will be using it, then you will see that many times you have to find such things, and then these operations will help you. So now these are very simple concept, and I request you to take some small data set and then try to see whether you are getting the same thing or not. Try to do it manually and then try to see whether you are getting the same output or not, because as I always say, it is very important to understand that what R is trying to do. So I would request you please try to practice it, and in the next lecture I will try to take up that how can you extend the concept of covariance and correlation in a similar fashion. So please try to practice it, and I will see you in the last lecture, in the next lecture. Till then, goodbye.